So we talked about did they say we talked about what we talked about ionic compounds. I told you ionic compound. They have free moving ions. Okay? They have an ionic lattice. The ionic lattice will not conduct. But aqueous solution mein what happens is that they have free moving ions which are charged particles and they can ye highlight bhi kiya hua, theek hai, they can move around and they will conduct electricity. And then you had metals and alloys. ठीक है, they had अच्छा उसमें था कि metals and alloys they would conduct. They have free moving delocalized electrons, which is why they're going to conduct. But nothing will happen to them. ठीक है, electrolysis जो था ना, electrolysis was what? It was start में I must have electrolysis was that it's the breakdown or decomposition of an electrolyte by electricity. So, but only compounds that have ions in them, ठीक है, the ones that have free moving ions, or basically ionic compounds, they are the ones that will break down. Not metals. Nothing happens to metals. So metals can't be electrolyzed. They will conduct electricity, but nothing will happen to them. And similarly, we talked about graphite. They have delocalized electrons, and I told you that nothing is going to happen to them as well. Electrons are going to come from one side, and they're going to be leaving from the other side. They'll just conduct electricity. Nothing will happen. The charges will move through them, but nothing will happen to them. And then I talked about the last thing I talked about was covalent molecules. I told you that covalent molecules never conduct, but because they don't have any charged particles, they're only sharing electrons, which is why they're not going to have any free moving ions or mobile electrons. They don't have any of those. So they never conduct. Lekin, similarly, I told you that there are some covalent molecules that will conduct, but the reason is that those covalent molecules hydrolyze, which means that they react with water. And when they react with water, they break down. Okay, so for example, HCl is a covalent molecule, but when you mix it in water, it breaks down in the middle and it forms ions, H plus 1 and Cl minus 1 ions. So once you have free moving ions, then they will obviously conduct. Okay, so covalent mein the only notable mention is that all acids that you've ever read about, they're all covalent molecules and they all break down when you put them in water. Okay, they all produce H plus 1 ions. But all of them are covalent molecules. Initially, they're all neutral. We all be color. If you have sulfuric acid, that's a covalent molecule. But if you mix it in water, it will break down and it will produce two ions. One of them is H plus 1 aqueous and the other one is SO4 minus 2 aqueous ions. So once you have free moving ions, they will conduct. Anyways, so we know which elements are going to conduct and which of them or which compounds are going to conduct and which ones are not going to conduct. Okay. Now, moving on. The only thing I'm going to recap, the only important thing is that you should know that metals, including graphite, graphite is, they have delocalized electrons. They conduct electricity, but nothing happens to them. Things that have free moving ions, they also conduct electricity, but they decompose when electricity is conducted. Okay, so make sure you know the difference. Up ye ke we've got we're going to start talking about electrolysis. But before that, we need to just have a quick recap about the formula of ionic compounds because this is just going to be a very quick recap. So we know the formulas of all the ionic compounds that we're going to deal with. So anything that's in, you got group 1, group 2. We wrote down the charges early on. Top I've written down the charges. We've written down the charges over here. Group 1 is what? It's +1. Group 2 is what? It's +2. Group 3 is +3. Group 4 could be +4, -4. Group 5 is -3. Group 6 is -2. And elements in group 7 are going to be -1. Remember, an ionic compound or an ionic lattice is formed when you have when you have a positive ion attached to a negative ion. So if I have sodium plus 1, sodium is plus 1 because it's in group 1, it's got one valence electron, and it loses that one valence electron. Oxygen is group 6. Group 6 is going to gain 2 electrons. It's always going to be minus 2. I said, remember how the formulas of ionic compounds are formed? That it's a crisscross method. Okay? So sodium is losing how many electrons? It's losing. Speak quickly. Now I'm going to tell you what the logic is. It loses 1 electron. Group 6 element is going to gain how many electrons? It's going to gain 2 electrons. It's got space for 2 electrons. A group 6 element will have 6 electrons in its outer shell. So it's going to gain 2 electrons. Now, the electrons that are being given by sodium are not sufficient. So what's going to happen is you need 2 sodiums. Okay, so the formula would be that you need 2 sodiums. So 2 sodiums combined will would lose 2 electrons. But you don't have to go into the details. You don't have to do crisscross. All you have to do is, I mean, you don't have to draw the dot and cross diagram. All you have to do is making the formula is simple. The shortcut is, if you want to know the ratio of the ions, there's a simple method, which is that there are going to be 2 sodiums and there's going to be 1 oxygen. Okay? And I told you the reason early on, which is that sodium lost 1 electron. Oxygen was gaining 2 electrons. So there's got to be 2 sodiums. Otherwise, the number of electrons lost and gained will never be equal. You have to make them equal. So you use the crisscross method to figure out the formula of ionic compounds. And that's your formula. And this is not, it's not just called formula. It has a particular name, which is called a formula unit. Formula unit is, it's the formula of the smallest possible crystal. Or in simple words, it's the ratio of the ions in the ionic lattice. So it's the ratio of the ions that are present in the ionic lattice. So iska yaad rakhna कि it's not just called the formula, it's called the formula unit. It's the formula of the smallest possible crystal when a positive and negative ion get attached to each other. What I mean by that is that if I have NaCl, Na is plus 1 and Cl is minus 1. So if you do crisscross, it's just going to be NaCl, right? 1:1. What this means is, it just tells you that the ratio of the sodium ions and the Cl ions in the crystal is 1:1, which means it doesn't mean there's going to be 1 Na and there's going to be 1 Cl, because it's a giant ionic lattice. So it's going to have a lot of sodium ions attracted to a lot of Cl ions.
Can you show the definition of formula unit?
मैं बताता हूँ. Just a second. So for example, this is your ionic crystal. That's the crystal, a salt crystal. So what the formula tells you is, or the formula unit tells you is, it tells you the ratio in which the ions are present, the simplest ratio. So if you have, in a crystal, you have 3 sodium ions, and you have, which are attracted to 3 negative Cl ions. So 3:3 is what the simplest ratio is 1:1. So remember, the formula unit is basically telling you the ratio. It's not telling you the actual number, it's telling you the ratio of the ions in the lattice. Okay? It's the ratio of the ions in the ionic lattice. Okay? And always remember, this is called a formula unit, not called the formula. Okay? So now, so keep this in mind. So the previous one, sodium oxide, remember, it's the formula unit is 2:1. For every 2 sodium ions, there's going to be 1 oxygen ions. In reality, in the crystal, the crystal is going to look, it's going to have a lot of positive ions, attracted to negative ions, which are then attracted to positive ions, which are then attracted to negative ions. So the crystal is going to have a lot of positive and negative ions stacked next to each other. But the ratio of the ions will be 2:1. So if the crystal has 2000 sodium ions, it's going to have 1000 oxygen ions. Okay? If it has 1 billion sodium ions, it's going to have, well, if it has 2 billion sodium ions, it's going to have 1 billion oxygen ions. Okay? So keep this in mind that the formula of an ionic compound or the formula unit of the ionic compound, it doesn't tell you the actual number, it tells you the ratio of the ions in the crystal lattice. ठीक है? ये clear है सारों को? Is this clear? Fatma here, Ruba, Nabila, is this clear?
जी सर.
तो बस इसके थोड़े से crisscross, ठीक है? We're just going to revise crisscross. Aluminium is what? Group 3. So group 3 will have a charge of +3. And let's say I have fluorine, which is group 7. Group 7 will have a charge of -1. So if I do crisscross, okay, remember the crisscross doesn't make sense. It's just a simple technique which tells you the ratio of the ions directly. Okay, so it's like a hack. So Al would be 1, you don't need to write 1, and fluorine would be 3. That means for every 1 aluminium ions, there's going to be 3 fluorine ions. As a plus the naming as well. The naming is, when it comes to elements, aluminium would still be called aluminium. The ion of aluminium is known as the aluminium ion. Its name doesn't change. The negative ion, I mean, this was fluorine, but now it's a fluorine ion. The fluorine ion is not going to be called fluorine. It's going to be called fluoride. Okay, so keep this in mind that the name of the negative ion of the element and I'm talking about the element, its suffix, the way it ends, that changes to ide. Okay, that changes to IDE. So कोई भी होगा ना, if it's sulfur, it's going to become sulfide. If it's chlorine, it will become chloride. If it's bromine, it's going to be bromide. If it's carbon, then it's going to be carbide. Okay, so there's an ide that's going to be written next to it. So for example, let's do another one. I've got magnesium and I've got phosphorus. Magnesium is group 2, so it's going to be +2. Phosphorus is group 5. So group 5 is going to have a charge of -3. And again, if I want to find out the ratio, the simple trick is just do crisscross. So the formula would be, there would be 3 magnesium ions and they're going to be 2 phosphorus ions. The name of this compound would be, so instead of magnesium and phosphorus, it wouldn't be called phosphorus, its end would become ide. It's going to be called phosphide. So just remember that when you hear the term ide, it means it's still the element, but the negative ion of the element. That's तीन चार और कर लेते हैं. Let's say I've got calcium plus chlorine. So I'm going to try and figure out the formula. I've got uh, aluminium plus sulfur, and I want to figure out what's the formula of sodium and nitrogen. So calcium is what? It's group 2. So it's going to be +2, and Cl is group 7. It's going to be -1. So the formula would be, if you do crisscross, it's going to be Ca1 and Cl and Cl2. So aluminium is group 3, so it's going to be +3. Sulfur is group 6. It's going to be -2. So the formula would be Al2 S3. Sodium is group 1. It's going to be +1. I'm just going to end it over here because we need to do electrolysis. N is group 5, so that's -3. So it's going to be Na would become 3 and N would be 1. You don't need to write 1. And I'm going to name them. This is calcium. And instead of chlorine, it's going to be called chloride. This is going to be aluminium. And instead of sulfur, I'm going to call it sulfide. This is sodium and nitrogen. And instead of nitrogen, I'm going to call it nitride. Okay? So ये basic चीज clear है? How to name ionic compounds? We're just revising so we can move on to electrolysis. Clear, is this thing clear?
Yes, sir.
Yes.
Acha, the next thing is we'll do polyatomic ions. We're just going to do a quick revision of polyatomic ions because ions are not limited to elements. There are sometimes what's a polyatomic ion? It's a molecule, a covalent molecule. Remember, the word molecule is always associated with covalent. Okay, whenever you hear the term molecule, that means a covalent compound. That means it's sharing electrons. So it's a molecule that actually ends up gaining or losing electrons. So as I said, it's a molecule that ends up gaining or losing electrons. So molecules, covalent molecules are formed when you have nonmetals because they don't like to lose electrons. Okay, they never like to lose electrons. So what happens in their case is, if, for example, I've got oxygen. Oxygen is in group 6. It's got 6 electrons in its outer shell. And you've got another non-metal, which is hydrogen. It's got just 1 electron. And so let's say there are 2 hydrogen atoms. Now, oxygen needs 2 electrons to complete its outer shell. So it's going to try and pull these electrons towards itself. But because the other one is a non-metal as well, no one is willing to lose electrons. So it's like three guys standing around. No one wants to lose electrons. This oxygen in the middle, he gets the bigger guy, tries to steal the electrons from the 2 smaller guys, and what happens is they're not willing to lose that electron. So what eventually ends up happening is that the entire atom gets dragged and pulled towards oxygen. Oxygen is trying to pull the electron, and they're not willing to let go of that electron. So the entire atom gets attracted along with the electron. Okay? So that's what a covalent bond is. No one basically is willing to lose electrons. So they're just fighting over electrons. It's like 2 people fighting over something, and no one is letting go of that. So they're basically sticking around. Okay? So, so that's what a covalent bond is, and they don't have charges. Why don't they have charges? Because no one lost electrons, no one gained electrons. So this is a water molecule. It's completely neutral. It's got no charge. No one lost electrons, no one gained electrons. That is when you get a charge. Okay, when you lose or gain electrons. But now what happens is, what if there is the second hydrogen atom is missing? So at the moment, the bonding of oxygen is incomplete because oxygen's outer shell is still short of electrons. It still needs an electron over here. It has to get that electron from somewhere. So let's assume the second hydrogen atom is missing. And in its place, you have, let's say, a metal atom, a group 1 metal atom like lithium. Okay, so if I have a group 1 metal atom like lithium, lithium is group 1, it's got 3 electrons. So let's assume the bonding of oxygen is still incomplete. There is no second hydrogen atom, so it has nowhere to look for a hydrogen atom, and there's no place, but it sees a lithium atom. So it's going to do exactly the same. It's going to try and pull the electron from a lithium atom, right? And that's what a metal is, right? A metal is always losing electron. It always likes to lose electrons. Taha, are you following this? I mean, Taha, I'm just going to explain this. Okay, right now. I mean, are you following this part that Oxygen's outer shell is still incomplete because there's no second hydrogen atom. Is that clear?
Yes, it's clear. I was talking about about covalent compounds. Like in covalent compounds, they don't gain or lose electrons; they share
Ye-
electrons.
yes,
I'm
exactly.
talking about the definition.
Yeah, so that's what I'm about to tell you. So if this part is clear that oxygen is still short of electrons, right? So right now it's a neutral covalent molecule, right? It's only sharing electrons, so it's not an ion. But oxygen needs an electron over here, right? So if the only option available to it is a lithium atom, right? And that's a metal, right? What does a metal do? A metal is always willing to lose electrons. I mean, that's the property of a metal. If somebody pulls an electron out of or attracts an electron from a metal, it always loses electrons. So this electron goes flying away to oxygen, right? So as a result, what has happened now is that you once had a covalent molecule, but that covalent molecule has ended up gaining an electron from lithium, which is why it's now going to have a -1 charge. And lithium is going to have a +1 charge. So it used to be a molecule, but its outer electrons were still not complete. And it saw a metal atom. It tried attracting electrons from a metal atom. The metal atom gave its electrons to oxygen so it can complete its outer shell. And as a result, the neutral covalent molecule has now ended up gaining an electron from lithium. Its outer shell is now complete, but it ended up gaining one electron from lithium, which is why it's got an extra electron, which is why it's going to have a -1 charge. So, Taha, is this clear that you once had a covalent molecule, but just to complete its outer shell, it ended up gaining an electron from lithium, and now it's no longer a neutral covalent molecule. Instead, it's a negative ion.
Yes, yes, sir. So right now, the compound is ionic compound or
Yeah.
covalent or still covalent.
It's a mix. Basically, now one part is covalent, right? But how did oxygen got the second electron? That was ionically. It ended up gaining electron from somewhere. So oxygen had to gain two electrons, right? I say you don't remember one thing. You don't have to go into a lot of detail. I'm just explaining the concept of what happens when a polyatomic ion is formed. It's a covalent molecule that ends up. It used to be a covalent molecule, but it's somehow its outer electrons were not complete, and as a result, it ended up gaining or losing electrons. And when it gained one electron, it became a negative ion instead. हाँ Shanzeh, we've read this. I'm just going to go through this very briefly क्योंकि वो electrolysis में you have to I mean this would be involved a lot in electrolysis. So so that's what a polyatomic ion is. Now the important thing is you don't have to do the dot and cross diagram. All you have to do is quickly you need to know the list of polyatomic ions. So I'm just going to write that list down again. So that list is you got sulfate, which is SO4 -2. That's a polyatomic ion. You don't need to know how those ions, each one of them are formed. You just need to have an idea that they were covalent molecules, but they ended up gaining or losing electrons and they became ions. You've got nitrate, which is NO3 -1. You've got carbonate, which is CO3 -2. You got phosphate, and that's PO4 -3. You've got what else? Ammonium. That's NH4 +1. Then you have sulfite, which is SO3 -2. You've got nitrite, which is NO2 -1. And hydroxide, which is the one that we did above, that's OH minus 1. You have to remember the list of ions by heart. You need to know each one of them. And there's more. There's magnate, which is of magnate 7. That's MnO4. Minus 1, you've got dichromate 6. That's Cr2, O7, and it's 2 minus. So, and there's other ones as well. There's hydrogen carbonate. You can take a screenshot because you have to memorize these ions. There's hydrogen sulfate. And that's HSO4 minus 1. Okay, so you need to know the list of all these polyatomic ions. And the formula of ionic compounds using these polyatomic ions is kind of exactly the same. So if I have aluminium carbonate, the formula would be written in exactly the same way, which is Al is group 3, so it's +3. Carbonate is over here. It's this is what carbonate is. And carbonate is going to be CO3 minus 2. So if you do crisscross, they're going to be 2 aluminiums and they're going to be 3. You're going to put a bracket and then you have to write 3. Okay, so if you do crisscross, there's going to be 3 carbonates and there's going to be 2 aluminium ions. Okay, that's what your formula is going to be for this compound. Okay, I'm going to share the older videos as well so you can have a quick recap. Acha, plus since we're doing electrolysis, whoever needs the older videos, just message me. Okay? So the other thing about, apart from these polyatomic ions, is you need to know the list of acids. Because acids are, they're going to turn into ions when you mix them in water. You need to know what ions are present in each acid. So for example, if there's hydrochloric acid, it's basically HCl, which is aqueous, which means that it's made up of H+1 ions and Cl ions. When you dissolve it in water, it's going to dissociate, it's going to produce 2 of these ions. So when you mix HCl in water, there would be 2 ions that would be floating around in water, dissociated, which means that the HCl molecule will split up and all these particles would mix around with water and they'll be floating around in water. Similarly, you have sulfuric acid. Sulfuric acid is H2SO4 aqueous. So when it is aqueous, it's going to be composed of 2 ions. It is made up of H+1 and sulfate ions, SO4 minus 2 ions. So when you dissolve it in water, it's going to produce 2 H+1 ions. You can remember the formula, there are 2 H+1 ions and there's 1 SO4 ion. So it's going to split in the middle and the particles would all mix up in water and the 2 ions over here will be floating around separately. Then you have nitric acid, which is HNO3, and that's aqueous. So that will Chandra SO4 minus 3 constant. It is a polyatomic ion. So you've got carbonic acid. I'm just going to do the main acids. That's H2CO3 aqueous. And it's going to have 2 ions. One is H+1 and the other one is CO3 minus 2. Both of them aqueous. And then finally, you've got phosphoric acid. Phosphoric acid is H3PO4. That one is made up of, if you dissolve it in water, it's going to produce 3H+1 aqueous ions, and it's going to produce one PO4, which is -3 aqueous ions. You can remember all these ions are from the same list that we just wrote down, carbonate and phosphate, etc. So all these acids you have to remember, I mean, these are the main ones. You have to remember all these acids, you have to remember their names, you have to remember their formulas, you have to remember the fact that if sulfuric acid is dissolved in water, it is going to split up and it's going to produce two hydrogen ions and one sulfate ion. Same with phosphoric acid. You should know that if you mix it in water there would be three H+ ions and there would be one phosphate ion separately floating around. Okay, so all these acids, they will form electrolytes. They will have free moving ions in solution and their electrolysis will happen. Similarly, all these ionic compounds, they're also made up of ions. You put them in water, they will dissociate and they'll also produce ions if they dissolve. I'm just going to do a couple of more, let's say ammonium sulfate, right? So what's the formula of ammonium sulfate? That's ammonium over here is NH4+1, and sulfate is given above. That's SO4 -2. Now, ammonium is NH4+1, SO4 is -2. If you do crisscross, it's going to be, there would be two NH4s and there's going to be one SO4. So you just write SO4, that's it. You don't need to put brackets around SO4 and write 1. So make sure that when this thing gets dissolved in water, the ions will split up and they'll be floating around separately in water. If aluminum carbonate is going to mix in water, it's going to split up and it's going to produce these two ions. Back again, they'll be floating around water. Okay, so remember, these compounds will dissociate when you mix them in water and they will produce their ions back again. Okay, they'll be combined together. You stir it with a spoon, all the ions, they split up and they scatter in water. Okay. Yantak, is this clear? This recap, is this clear? Okay, what ions are going to be produced in aqueous solution? And you got to remember these, all of these. Okay, or plus I'm going to share a video lecture which is going to be a short crash course on this, where you have to remember all these ions. I said, plus the trouble, there's one more thing which also needs to be memorized. And that's also pretty hard to memorize as well. And that is the solubility table, because not all of them are going to dissolve in water. So not, if we go back all the way up, remember the ionic compound, not all of sometimes the attraction between the ions is so strong that no matter how hard you stir it in the water, the ions are not going to get scattered. They're not going to get dissociated in water. So a lot of ionic compounds, they dissolve very easily, but some of them are really hard to dissolve. For example, marble is one of them. You take a piece of marble, the ions are so strongly attracted to each other that no matter how hard you try, take a piece of marble and try to dissolve it in water, the ions are not going to get scattered in water, and it's not going to happen. So for that, you need to remember what the solubility table is, because not all of them are going to dissolve. So there's another thing that you got to remember, which is, so I'm going to write this again as well. This is going to be helpful in electrolysis as well. I mean, you can't do electrolysis if you don't know the fact that which compounds are going to dissociate in water and they're going to produce ions, and which ones are not going to dissolve in water. So solubility table is, it's going to tell you which compounds are soluble, which ones are not soluble. So I'm just going to make I'm going to make I'm going to split it up into two parts. This side is where you have soluble, and the other side is the part where you have the insoluble compounds. So starting with the first one, anything that's got group 1 or NO3 minus 1 or NH4 plus 1, and there's one more, or acids. They're all soluble. Okay, so they're already on the soluble side. So these compounds are all soluble. So Na is group 1. So if you see a compound of Na that belongs to Na, it is going to be soluble. And it will, so NaCl will dissolve in water and it will dissociate and it's going to produce two ions, sodium ions and Cl ions, and they'll be floating around in water. Second one, sulfates, most of them are soluble. So SO4 minus 2. So they're mostly soluble. Except there are some which are not soluble. So very few, I mean, most sulfates, whenever you hear the term sulfate or it has SO4 minus 2 in it, it's very likely to be soluble, but there are a few that are not soluble. So, and those few are, you've got barium sulfate, you've got strontium sulfate, you've got silver sulfate, there is lead sulfate, and there's calcium sulfate, which is partially insoluble or somewhat, I mean, it's or very slightly soluble. It's kind of in between. So sulfates are mostly soluble, anything that's got SO4 minus 2 in it. Now, number 3, you've got chlorides, bromides, iodides, and they're also mostly soluble. But they have an exception as well, except the ones that have silver ions in it or lead ions in it. So, for example, lead chloride is not going to be soluble. So, an example is PbCl2 or AgCl as a fourth point. So, anything that's got Cl, Br, or I, that is very likely to be soluble. Except if it has Ag or Pb in it, then it's not soluble. Okay, Ruba, we're going to end this class in 2 minutes. एक और comment अच्छा the fourth point, we'll just complete this and then we'll end it over there. What other compounds do we have? We've got sulfate, we've got carbonates and phosphates. Now the thing with carbonates and phosphates is that they are mostly insoluble. So anything that's got PO4 or CO3 minus 2, they are mostly insoluble, except for a few that are soluble. So except which we told already, group 1, NH4 plus 1, or the ones that have acids H plus 1 in them. So if you have H3PO4, that's going to be soluble. So who's left? Hydroxides. So oxides and hydroxides are also mostly insoluble. Except group 1 oxides and hydroxides, they are soluble. And some in group 2. Otherwise, most of them are insoluble. So some in group 2, for example, You've got barium hydroxide. You've got strontium hydroxide. That is also soluble. And you've got calcium hydroxide, which is partially soluble. But that's kind of in between. So oxides and hydroxides, they mostly fall into the category of insoluble compounds. But with if it's got group 1 in it, it will probably be soluble. If it's group 2 in it, some in group 2. Barium hydroxide or strontium hydroxide is probably going to be soluble. Okay. So that, did I leave anyone? That pretty much covers the soluble and insoluble compounds. You can remember group 1. I'm just going to recap. Anything that has a group 1 element in it, that compound will be soluble. Anything that's got NO3-1 in it, or NH4+1 in it, or H+1 in it, all of those compounds are going to be soluble. If it's got SO4-2 in it, it was very likely to be soluble. If it's not one of these ones are going to be insoluble. Otherwise, the rest would all be soluble. Chlorides, bromides, iodide, most of them are going to be soluble, except for the ones that have silver and lead in them. Carbonates and phosphates, most of them are actually not soluble. Except for the ones that are soluble that have group 1 or NH4+1 or H+1 in it. And oxides and hydroxides, they also mostly fall into the category of insoluble compounds, with a few exceptions, which are that group 1 of them. So basically, group 1, anywhere you see group 1, they will be soluble anyways. Okay? So you got to remember, this is very important for electrolysis, because if a compound is not soluble, it's not going to turn into, or it's not going to dissociate into aqueous signs. It will not mix in water. Okay? If it's not soluble, it will not split into ions, and there will not be any free moving ions, and its electrolysis will not be possible. So electrolysis is only possible when you have free moving aqueous ions. And for that, it's important that your ionic compound, it mixes in water. If it's not mixing in water, you can't do electrolysis. You need free moving ions for electrolysis to happen. चलो ठीक है, ये ज़्यादा हो गया. I'll share the notes right now, and because there's a lot of stuff that you got to remember, especially the polyatomic ions plus the solubility table. ठीक है? So we'll continue tomorrow then. ठीक है? हाँ, Shandra, sorry, I'll share the recordings today, all of them. ठीक है? Okay, take care. Hafiz.
Hafiz.